So another thing we can do is combine Boolean or comparison operators with Boolean operators. So I'm going to add another program to demonstrate this called Boolean Operators Demo. And let's get a number is equal to int input. Please enter a number between 1 and 10. And so we're going to get a number. We are going to check to see if number is in correct range. Well, right now what we could do is we could say if num is less than or equal to 10, and then we could check if num is greater or equal to 1, and then if it meets those two conditions, then that's great. And else, we're going to say wrong. And then here, we're going to put another else, because if it isn't less than or equal to 10, well, then that's wrong too. And this looks kind of weird. We've seen this before where, okay, we've got two identical statements. And if you're a programmer, you kind of don't like seeing identical statements because, well, you'd like those to be together. So let's see if this works first. And so we have three conditions we need to check. Will it detect if it's too low, if it's too high, and then if it's in the right range? And actually we have two edge conditions. What does it do with 1 and 10? So we kind of need to run this about 5 times to really test it. So let's see. Let's try too low. So I'll put 0, which is okay. Good. So that detected that, and then I'll run it again, and then we'll check 1. Okay, that's good. We'll run it again, and then we'll check 10. Okay, that's good. I guess we have 4 edge conditions really we need to check. And then let's see, we already did 10. Let's see what it does with 11. Okay, so it looks like it's working just fine, but we can actually simplify this. Really what we're saying is num less than or equal to 10, and is it greater than or equal to 1? And we got to get rid of this colon here. So if it meets this condition and it meets this condition, then it's in the range. Otherwise, it's wrong. Let's see if we can write that again. So let's see. We're going to try that. Okay, that was correct. And then we could check 1. Okay, that's good. And then we could check 10. That's good. And we could check 11. And that's correct too. So this is working, and it's much more concise code. So you can use and what you'll find is it doesn't really matter which order these two things are in. And it probably looks a little better this way. if number is greater than or equal to 1 and number is less than or equal to 10. And sometimes you find, depending on the way you think about your logical expressions, some ways of structuring this will work better than for some people than others. I'm just going to do just a few checks here. Yep, that's good. Oh, put it in the wrong spot. It needs to be here. Okay, that worked. I guess we should go and validate that all of them work. Just to show you that this is all of these statements are logically equivalent, even to the original multiple nested if statements. But I think that this reads a little bit better. So we have and or, and you can use them to combine multiple comparison operators together and Boolean expressions in general, and make much more complex logical expressions about that you can solve problems. So this works well. The other thing to remember, we can also write this with chained operations by saying if 1 is less than or equal to num, which is less than or equal to 10, and this is another way you can write it, and this will work as well. So whether you use chained expressions, or you use the logical operator, or you use the, there's several different ways of doing the same thing with logical operations. And which one you pick, in large part, is governed by, maybe how you think about the problem. And we can see this is working the same way. So I'm going to go back to, if num is greater than or equal to 1 and num is less than or equal to 10, that's what we had before. There's another way you could write this, actually. You could also say if number is less than 1 or num is greater than 10. Okay, so this is actually the opposite of this. So these two logical expressions are opposite. They will return opposite results. But we can flip this around here, and now, because we switched what the results were in the if and the else, these will produce the same result. And let's see. And watch this. So if I put 0, we got wrongs from both of them. And so they both resulted in the same thing. Now let's run it again. And put in 1. And again, they both had the same result. In fact, there's two other ways of doing this. There's 4 different ways of treating this, and we could put a not in front of here, and a not in front of this one. Let's do it this way. So the not operator reverses the results, And effectively, then we have to switch these up again. And so these will also result in the same thing. So let's see, I'm missing something. So we have num greater than or equal to 1 and less than or equal to 10. We have num less than 1 or greater than 10. We have, okay, yeah. So we got this one, this one, this one, and this one. So we got 4 possible ways of doing this. And they should all return the same results. Yep. Try a result that's false. So these are all logically equivalent, and basically, if we flip the if and the else block, that's the equivalent of putting a not in front of the Boolean expression. And if you take the inside parts and do an and, that will be the same as taking the outside parts of an or and putting a not in front of it. So this can be kind of interesting to look through and kind of walk through and understand. And if you understand why these are all logically equivalent, most likely you're going to be able to understand how the and or operators work. All of these are fine. You can write them any way you want as long as it works properly. Really, the best way of approaching this is when you come to a situation where you need to write a logical expression, put in your best guess and maybe build your way up to it. Like just do, one of the comparisons and test that, then do the other comparison, maybe even nest it if that makes more sense to you. And then see if you can simplify it and refactor it and make it cleaner and easier as you go. So, I'll find situations where I'll write a logical expression, I'll test it. It may work, but I kind of want to clean it up, and I'll rewrite it a couple times until I get it to make sense, so that when next time I read that piece of code, it's easy to see what's going on. Let's go look at this nested if demo and see if we can simplify this. We have a lot of situations in this one where we had not numeric, not numeric, not numeric. So I'm going to copy this code, and I'm going to make a new program. And let's see, what was this doing? This was is numeric with Boolean Operators. .py. Kind of a long name, but it'll work. And so I'm going to paste this. Oh, we didn't get the whole thing. Let me grab this previous demo that we did and paste it in here. Yeah, I don't want to change the original one. And so if we looked at this, remember we printed a header, we got the user enter number, and if you recall, to check to see if this is numeric, we had to see that there's only one of these and that there's only one minus, and we made this temporary variables to get rid of the extra to get rid of these, and then we check to see if something is numeric, and then and then we got this to check. So I think we can simplify this, at least these two initially, by using an AND operator. And so what we could do is, let's take this and let's put this at the top. And we can actually, there's no reason we can't do these two operations at the beginning to get user inputs without a point and minus. And then that means that now, well, I could do this with an AND. if the user count of this is less than 1 and the user count of these is less than 1, well, actually, then we could put these two. Maybe we'll put these right here because no need to do those unless it passes that test. And let's run the original one. Oh, and then now we don't need, and because we did that, we can actually get rid of one of these else's because, you know, we're doing this all at once. And since they both have the same result, we might as well do them with an and up here so we can get rid of one of these else's. And let's run the original just to see what that looked like. And then, you know, if I put in that, it says it's not numeric. And then if I run it again, it's numeric. Okay, great. So that worked fine. Now let's see our new version with an AND operator in here. And let's see, not numeric, and then run it again. We're not doing for a very thorough test, but we'll test it a little bit. And then let's see, 1, 2, 3, 4.5. That's numeric. Run it again. And let's see. Let's put 1, 2, 3, 4 dot this, and then put 2 periods in there. Not numeric. It figures out that that's 2 bitty dots. So it looks like this is working fine. I'm going to get rid of this print statement just to kind of clean this up a little bit. And let's see. Well, can we get rid of this extra one? Possibly. What we could do is, we need these calculated first, but we could take these logical expressions and put an AND here. And so what we're going to do is we're going to check to see if, and then we can get rid of this, and we can get rid of this else. And tab that back in here. Looks like we missed something there. Okay, so now what we're doing is make new string without dot or minus. So we're making this user input without minus, and we're going to check to see if that's numeric, and we're going to check to see if the counts of the dots and the minuses are less than 1. Now, one thing with the AND operators is that they shortcut. So it's often a good idea to do the least computationally complex operation first. And here it's not necessarily super clear. I think this count operation may actually take less processing power than this one. So I'm actually going to put this one at the end. So I'm going to cut this and make it like this. Because if it fails this first test, it won't do the others, and we'll save some processing. Then it'll do this one, then it'll do this one. And so now we've simplified this code quite a bit. Looks like I'm missing my goodbye. And so let me clean this up a little bit. Okay, so we get the input from the user. we get rid of the dots, we get rid of the dashes, minuses. We're checking the counts of these on the user input here. Note that we didn't modify the original one, so we can check to see the count of minuses and the dot, and then we can take this one that we calculated and then see if it's numeric, and if it is, then everything is meeting our requirements, and then we can go in and do this additional check here to see if it's positive, negative, or zero. So so this should work now. Let's try it out. And we'll put 1234.5678. It's numeric and it's positive. So yes, that worked quite well. Got a goodbye message. So this is now working, and we've cleaned it up by using the AND operator. Now, could we have done this a different way? Could we have counted if the count of this was greater than 1, or if this was greater, if the minuses were greater than 1, and done it that way? Yes, absolutely. So you could have written this in a number of different ways, and you can use that to make the logic of your program cleaner. So AND and OR operators allow us to combine, and you can see you can put more than one pairs of comparison operators together with multiple ANDs and ORs. And if you're not sure which order things are going to execute, you can actually put parentheses to force the order of operations. AND operators, just like any other mathematical operator, there's an order of operations. Your ANDs are calculated first, then your ORs, then all your mathematical calculations are done. So and the order of operations can be forced with parentheses. So that's how we can use the Boolean operators.